So hello students, let's try to solve the another part of the question set student, that is from the question number 13 onward we are going to study, right? So what is the question number 13? You can check it. Calculate the half life of a first order reactions from their rate constant given below. So this is what the question is, student. So student, they are talking half life. So if I will ask you what do you mean by half life, so when anything, okay, become half of its the initial concentration, that is called half life. And there is expression for half life, student. What is the expression? It is called, that is t1 by 2, means t half is equal to 0.693 upon what is, student? K. What is their rate constant is given. Rate constant means k is given. So suppose you are solving the problem number 1, student. So what is t1 by 2? What you can write, student? It is 0.693. And what is the k value? It is 200 second inverse, right? So this is what the point. Now you just solve this, student. Solve and check out the what the answer is going to come, student. Let me check whether I am being on live or not, student. Yeah, it's very much audible. Thank you very much. So here second will go on the numerator, student. So second inverse will convert into what? It will convert into second. So let me solve, student. 0.693 divided by, it is 200. So it is coming, student, 138.6 second. So this is the t half. In this much of time, student, in this much of time, the reaction will become, the concentration will become half. Okay. So total reaction is completing in 200. You can say not 200, rate constant there. So it will be the double of it. Now let us try to go with the second one, student. What you can do second one? So that is t half is equal to, here I am writing t half is equal to 0.693, student. That we will write t1 by 2. So 0.693. And what is the k value? 2 minute inverse. Minute inverse. So if you divide this, student, 0.693 divided by 2, student, so it is coming 0.3465 second. Here is the wrong, student. This is not the correct one. I am extremely sorry. In spite of divine, I just put the multiplication sign. So here is, if you are dividing by 200, so it is going to give, student, wait a minute, student. So it is coming 0.0034. You can divide also, student. And in the scientific form, if you are writing, student, 3.4 into 10 power into, it is 10 power, how much it is going, student? Minus 2 seconds. So this is our required answer for the first case. Now go for the third case, student. 4 years is there. So third one, if you are solving, student, so t1 by 2 is equal to 0.693 divided by 4. So if you divide by 4, student, so how much the answer is coming, student? It is coming 1.7 into 10 power minus 1, and it is the years, student. This is, or in the other form, if you are writing, student, 0.17. Okay, this is what, student? Years. So this is what the t1 by 2. This is our required answer is coming. So this is very simple, student, where you need to put the value in the expression t half is equal to 0.693. Let me check out the values whether they are correct, student, or not. So first one is there, student, 3.46 into 10 power minus 3. 3.46 10 power minus 3, student, because decimal is shifting to 3 digit, so it will become the minus 3. Second one, if you see, student, it is 3.46 into 10 power minus 1. So that is correct, student. In the form of scientific figure, 3.46 into 10 power how much will come? Minus 1 second. And last one, student, 1.73 into 10 power minus 1 years. So that is what is the, this is the correct, student. Now let us move out the next question. What is the next question? Question number 14, student. What is the question 14? If you see, they are saying the half life of radioactive decay of carbon 14 is 5730. Okay, so what is there, student? T1 by 2 is equal to 5730. It is the years, student, years. An archaeological artifact containing wood had only 80% of the C14 in living tree. So estimate the age of the sample. So T they are asking, student, and if you are writing R naught, suppose it is the 100%. So RT how much is left, student? That is only 80% is there, means 80 is there. So first of all we should calculate K, student. So K is equal to, if you are writing 0.693 upon what it will come, student? T1 by 2. So here if you are plus putting the value 0.693 and T half value you can see, student, 5730. Okay, this is the 7, student. So now plug just see the value how much coming, student. 0.693 upon 5730. So it is coming, student, how much? 0.0001209. It means 1.2 into 10 power minus 4. This is what is the years. So this much is not the years inverse, student, years inverse, first order reaction now. So this is the K value we are getting. Now if you got to know the K value, student, you can put 209 also. Let us take the all the value. Now what we have to do, student, here K value we got to know. So they are asking T value, in what time it will reduce to 80%. So T is equal to 2.303 from the first order divided by K. Here is log is there. It is R naught upon what is there, student? R. So 2.303, student. K value how much is there? 1.209 into 10 power minus 4, student. And here is what is there? Log. R naught value initial will be 100. So final will be how much, student? This will be the 80. Now solve this. How can you solve this, student? So something is getting cancelled out. What is cancelled out? 1 0 cancel out, student, right? So let it be like that. So 2.303 multiply by 10 power 4. It is the in the denominator minus 4 is there. Numerator it will become 4. So 1.209. This is, here is log, what is there, student? 10 by 8. So log A by B means log A minus log B. So log 10 minus log 8. Okay, student. Now let us solve it. So if you are multiplying this value, it will 23030 divided by 1.209, and log 10 value is 1. And here what we can do is, student, log 8 is equal to, how to write it, student? Log 8 is equal to log 2 power 3, because we know 2 into 3, 2 is equal to 8, 2 to 4 to 8. So it will become 3 log 2. 3 log 2 means, student, 3 into log 2 value 0.3010. So if you are solving, student, it will come 0.309. So 0.9030. Here 0.9030. Now here see, student, 23030 divided by 1.209, and here is, if you are solving, student, 1 minus, you plus the, put the value, student, 1 minus point, it is, see, 1 minus, it is point, student, 9030, so it is coming, student, 0.97. I am plus putting the value 0.097. this is. Now let's see the next one, how much the value you are going to get, student. So 23030 divided by 1.209, so 1847 years will come, student. 1847 years. The life of the plant is T is equal to how much, student? 1843. So here you see the question they are asking, student. The half-life is okay. An archaeological artifact containing wood had 80% of the C14 found in living tree. Estimate the age of the sample. So age of the sample will be how much, student? 1847 years. So this is all about the answer. Now let us move on the next question. Here, see, student. Question number 15. The experimental data for decomposition of N2O5 is this one. Gas phase they have given. Plot the N2O5. N2O5 decompose. N2O5 is, student, it is the first order. Its decomposition is first order. This is example of what, student? First order. So they are saying that is plot the graph against N2O5. This is given N2O5 and time. So it's very simple, you can plot the graph, there is no problem at all. Sorry, student, here it is not getting erased because there is the border is there. So let us see, put the value. So one side we are putting the time, student, and another side concentration of N2O5. This is, student, let us put the value time. So where the here is the 0, then it is the 400, then it is going to be 800, then it is going to be 1200, then it is going to be 1600, then it is going to be 2000, then 2400, then it is 2800, and finally 3200. So these are the datas are there, student. Now if you can see here, concentration, friend, so initially 1.63 is there, at the 1.63, next one 1.36, next one 1.14, next one 0.93, 0.7. Oh, sorry. Initially, this is the reactant, student. So reverse order we have to write. Firstly, the concentration of the reactant will be highest. So here you can put out the value 1.63, then 1.36, then 1.14, then 0.93, then 0.78, then 0.64, then 0.53, then 0.43, then 0.35. This is there. So when the time is 0, this is the 163. So here this will come, student. So here is 0 comma. Okay. So when the time is, student, how much is there? So here on the top it is there. So 0, it is 0. Let's see, student, the screen has gone here little bit. It will take a moment. It's actually when you are writing on the border na, it will disturb. So I by mistake I wrote on the border. Let us, I will not go here. So the first point is what there, 0 time is there na, comma 1.63 is there. So this is what the first one. Now student, the second point you see 400 and 136. So here is the 136, but it is the order will be where you will find student this one 136. So what the point it is called, go student 400 comma 1.36, this will come. Now the next one, what the point is there student, 800 1.14. So somewhere it will go student here. So at the 800 it will be here student. So 800 is there, and here 1.14 is there. Now if you see 1.14, 1200, at the 1200 0.93 is there. So here student here, so it will come here something. Now the next one is what they are student, 1600.78. So let's see, it will be like that. Then 2000.64. So here you can come here, this one. Next one is student 5.53 2400. So it is coming like that, this one. Similarly it will be like that student, here this is, and finally this will be here. So let us draw the graph student, how the graph is going to be. So this is starting student here, this is, see the graph how it is coming student. This almost the graph is showing the straight line student. This will be straight line. So since it is a straight line student, this is the going to be first order. Since the slope is straight line, so it is first order. So one thing we got to know student, now find the half-life period from the reaction. So what will be the half-life period student, half-life period? So when the concentration become half, that will be the half-life period. So see 1.63 is their initial, right? You divide by 2. So what is there, 0.8. So 2 8 ja 16, 2 1 ja 2, 2 5 ja 0.815. Where you will match 0. Here is there student 1.14. So here is what is there student, 0.93. And we need the, this value is between the 1.14 and 93. It means it will be, the value will come where this value is going to be appeared student. This value is going to appear here somewhere. This is, this value is what student, 0.815. So what is the time here student? Time is 1500. So T half is student, T half is equal to, it is something 1500 approx will come student, 1500 second. So this is what the second number. Draw the graph between log n205 and t minus. This you can draw student. You need to find the value of log of this, log of this, log of this, then plus the plug the value, you will get the log, the straight line. What is the rate law student? So fourth one, if I will explain rate law, so rate is equal to, this is first order reaction now. So it is N2O5 and power will be what student, 1. So this way you can be able to solve the problem student. Now let us move on the next one student. What is the next problem? Question number 16 we are going to solve student, and we'll check that what can be the answer. So in case of question number 16 student, you see the rate constant they are talking student. What? Here you see the rate constant of the first order reaction is 60 second student. This is the 60 second. So K is equal to 60 second inverse. how much time will it take to reduce the initial concentration of reactant to its 1,6? So if suppose it is the initial is there student, r naught is there a, so rt is equal to a by what will be there 1,6 student, a by 16 this will be. Now if I will solve this problem student, so what will be the coming answer? K is already there, so t they are asking now. So T is equal to what is the first order reaction, because they are talking about first order. So 2.303 upon it is the K log. What is the initial concentration R naught upon RT? So here what is there student, 2.303, K value 60 log R naught is the A. R naught you consider A. So here is 16 is there, A by 16. So a by 16. So what will be there if you are solving? 2.303 student divided by 60 and log. So it will be here sorry the C student. So whatever the there in the denominator, this will go in the numerator. So 16 A by A. So A will be cancelled out student, right? So it will become 16 will left, 2.303 upon 60, and here in log student log 16. Here is there student 2.303 upon 60 log. What will be there student? 2 power C, 2 into 2 into 2 into 2, 2 to the 4 to the 8 to the 16. So power will be what student? 4. So here is the 2.303 upon 60 and 4 log it will be 2. Log 2 value everybody knows student, 2.303 upon 60, 4 into student, well, log 4 0.3010 student. Now you plug out just you solve it student, solve it. So let me do the little bit calculation student. 2.303 student multiply by 4 multiply by 0.3010. So it is coming dear student, how much coming? 2.7728 divided by what is there? 60. So let us divide by 60 student. It is coming student, it is 0.04621. It means 4.6 into 10 power what is there student? Minus 2. Now unit you see student, unit what can be the, because time you are calculating a second is there, so this will come in the second. So this is what student? Second. So this is the T value. So in this much of time student, in this much of time what will be there? Reaction become 1 by 16 time, you know, reduced to 1 by 1/6. So the rate constant of first order reaction, this one, how much time will it take to reduce to initial concentration of the reactant to 1 by 16 part? So it will take how much time student to reduce? 4.6 into 10 power minus 2 second it will reduced. So now let us move in the next question student. So next question we are going to solve in the another video student. I don't want to make the video too large, too longer time. Thank you so much for watching friends.